So let's do a couple more of these. I accidentally erased my wonderful graph. So I replaced it with these two schematic diagrams, which are something like it, where we identify the place where we're looking at in each of these examples, so we know how much of the curve to take because we know how many bars we're using. So we're adding up the bars, the areas of the bars, to get the probability. And so first question was the probability is x is binomial. The binomial quantity is at least 20. So that's greater than or equal to 20. That's at least 20. So at least 20 is from here over. So we want the area from there over. So it actually starts at 19.5. So we're going to use x equals 19.5 for that one. And then we're going to look it up in the tables, and then we're going to subtract from 1 because this is above. Otherwise, I could just look it up. And for at most 20 is less than or equal to 20. So it's 20, this bar and left, all the bars here like this. So if you want to get the area of this bar, you have to start at 20.5. And then we're just going to compute the z-value and look it up in the tables. Okay, let's try that. So we use the z-value. So 20.5 is the x, minus the mean was 18, divided by the standard deviation, 3.1464, like that. Okay, that'll give me the number of standard deviation away from the mean that 20.5 is, and then we're going to look up the area left, and that'll match this area here left of 20, including 20. Okay, so that would be 20.5 minus 18. It is. And take that and divide it by 3.1464. Okay. 0.794. We have to round it. 0.794. We rounded to 0.79. Okay, and then we'll try the same thing here as long as we're making z's. I'm making z's, I'm sleeping. That's even better. 19.5 minus 18 over 3.1464. So then we go 19.5 minus 18. Get that divided by 3.1464. So after I get done making these videos, I might spend a lot more time talking to myself. That's 4767, so 0.48 rounded. Yeah, when I'm working on my own homework at home, I can be talking about it to myself. That should be nice. It doesn't seem that weird in here now that I'm used to talking to nothing, just the blank black wall I'm looking at. But I just keep imagining there are people actually watching me. Maybe that works. Here we go. So this over here, this says, here's how we figure out how to set up the normal approximation. We think of the bell curve, we think of the bars in the histogram, we think about which bars we need to add up, and then the area under the curve has to match the area under those bars, so which bars am I using? Who is the bar all the way to the right and all the way to the left in this situation? And then that means I have to go plus a half or minus a half depending. That's how it's 19 and a half. A little bit bigger, a little less than 20, and here a little more than 20 just because of the direction I'm trying to measure area in. And then at least, which one we say? We said if it's less than, we can just look it up. So we look 0.79 up in the table. This is like deja vu for me. 0.79, it's way over here. 7852. That was 48. 48. No, it wasn't. That was 79. Was it? 7852, sorry. So we said for that one, that's the actual answer. I think that's right. Let me double check that in a minute. And then I'll go to 0.48. 0.48, 6844. 68. Not how good it does to be careful. 6844, like that. So it's for less than, that's the answer. And it says for greater than, it's 1 minus that. So 1 minus 0.6844 is 0.3156. So 1 minus 0.6844 is 0.3156, and then 0.7852. So for 1 and for 2, the answers. Okay, 3156 and 7852 off of the tables. And then we've got this guy here, just to finish this off. X is between 14 and 24 inclusive. Let's try to sketch that out. So here's the bars. The bars are centered on the values that are possible. That's how those things are drawn. And that's how the normal approximation fits them. If the bars are centered on the integer values. And they're with 1. Okay. Oh, in that case, of course, the area of all those bars matches exactly the area, the total area being 1. So we don't have to do any rescaling or anything with this one, the way we have it. Well, hang on. If those were probabilities, we wouldn't have to do anything, but we had it scaled here with number of observations. So it wasn't a probability histogram. So since it wasn't a probability histogram, we do have to rescale it. If it had been a probability histogram, it would have matched exactly. It would have been great. Seeing as we don't have either one right now, we'll just go with this. So to get between 14 and 24 inclusive, I have to find the area from a little bit left and a little bit right. A little bit left of 14, that's 13.5. A little bit right of 24 is 24.5. So I got to compute z's for each of those. So let's do that. So z for the 24.5. And z for the 13.5. Like that. So this one ought to be up there, maybe in the 1.8 range. Let's see what it looks like. 24.5 minus 18. We're going to divide that by 3.1464. 2.06, 2.07 rounded. 2.07, so bigger than I thought. And then 13.5 minus 18. Divide that by 3.1464, which my calculator will not type. There it is. Negative 1.43. So that makes sense. It's below the mean. It's about 1.5 standard deviations, and this is 2 standard deviations above. And then we look up the areas for 2.07. And these are areas for standard normal. The approximation. So for 2.07, 9808. And for negative 1.43, oh yeah, I got the tables here. That's how I'm doing it. I'm not actually cheating. Hopefully I'm getting the right answers. Minus 1.43, 0.764. So the answer we want is the big area minus the little area. So this is a little bit further over than I have it drawn, I guess, because mine. So it doesn't. That looks like about not even 1 standard deviation. So it's more like here. But that's okay. It's just a schematic. So 9808 minus 0.764. 0.9808 minus 0.0764. 9044. Okay, so we use normal approximation to find a less than, a greater than. We had to translate this at least 20 into greater than or equal to 20. We had to translate that question into which bars am I adding up, and where do I have to start to make that happen? 19.5. And then at most 20, we translated that into x can't be any bigger than 20, but it's allowed to be equal to 20. So less than or equal to 20. And that's 20 or less. That's all these bars from here back. So we want to start at 20.5 under the curve to get the area. So when we compute z, we use 20.5. Well, we got 0.79. The area left, right around 7.8, the area and the number of standard deviations matches. It can be confusing. So this is standard deviation, that's area, that's distance, that's area, different units even, okay. And then if we're doing the, find the less than probability, that's what's listed in the table. So that's right there, that's the right answer. This is a less than, I want a greater than, so I have to subtract it from 1. We already picked the right place to do it. So where we have it chopped, the stuff left above is the greater than. So we're chopping it at 9.5, so we include 20 in the greater than or equal to category. And so we don't have to make any adjustments except subtract this from 1. And then when we go between 14 and 24, we have this picture here. And to get the area, and including the bars, 14, it says equal to is allowed. So x can be 14, x can be 24. I want the area of this bar down to the area of this bar. So I need to start at 13.5 up to 24.5. I put them in the z values, into the z-score calculation. I get these two z values. I look up the areas. Then I subtract the areas. And that's our answer. All right. That is the end of Chapter 7, to my knowledge. Unless I skipped recording one on my way here, which I might have. And then I can, if that's true though, I can move on to Chapter 8, and we're getting closer to the end, which gets really exciting after a while. Probably even more exciting for you guys because all that homework and all those things like that, that starts to weigh you down. But on my side of it, making these videos day after day, I make, it depends, maybe 6 to 8 videos on a given day. So that maybe that covers maybe 3 sections. I've been doing it every day for a long time now. And when this stops, I get to stop talking to myself and I get some free time. But I've got to get this done before the fall semester starts because this is what we're doing in the fall in one of our classes. And if you're here, you know we did it. And if I'm talking to no one because we couldn't get the class running, well, I'll be talking to you in the spring. Let's just see what happens. And hang in there, right? Because we're getting close to the end of the deal. And what happens here as we get down the line is a lot of the pieces of the puzzle start being used at the same time. So those things that you didn't quite figure out along the way, you're going to be called upon to use. Now, of course, that's in a way good because it makes you refocus on those things and maybe learn them in a different way and finally come to understanding them. But it can also be challenging at that point if you let something slide and now we need it. You're going to have to go back and review it and figure out what's going on so that you can finish problems that involve several steps. And the steps involve a bunch of different things that we've done before that really we didn't care if you were really good at it then, but all of a sudden we're going to start caring because you can't get the answer unless you can do all the steps. So with that, and saying goodbye to Chapter 7 and hello to Chapter 8, have a great day.